and welcome. So I'm gonna try to help you solve this problem. So the first step we're gonna do is just replace our y prime by r squared and then y by 1. Why? Because in differential equation y second prime is r squared, y prime is r, y is 1. That was our first step. Then the second step is going to be solve for r. So we're going to do equal 1 over 36, and r equal square root plus minus of 1 over 36. So we have r1 equal 1 over 6 and r2 equal minus 1 over 6. Then after, I'm just gonna add like our toolbox here. Okay, so in our toolbox, we remember that there is three case. The three case. So there is three case. So first we have like an equation looking like a y squared plus b y prime plus c equals 0. And we want to solve this. So we have three cases. Case 1, we're gonna have our delta equal b minus 4ac. We're gonna make it equal to 0. That's our first case. So our first case, it's gonna tell us that like it seems delta is equal to 0, then you're gonna have only one r. And therefore our answer is gonna be C1 ERX plus C2 ERX. That's for the first case. Now the second case, if our delta is bigger than 0. So in this case, we're gonna have two solutions, R1 and R2. And our y equation is gonna look like C1 ER1X plus C2 ER2X. Now for case 3, if delta is less than 0. So if it's less than 0, our y is going to be E alpha x, and then we're going to use cosine, like it's like an imaginary, we're going to use like imaginary answer, which is cosine, right? So our answer is going to be C1 cos beta x plus C2 sine of beta x. Okay, now let's go back to our exercise. Our exercise, we found 2r. So we're gonna use case 2, right? When we use case 2, we found that y equal C1 ER1X plus C2 ER2X. So now that we have this, we're going to replace it by what we found above, equals C1 E1 half or 1 over 6x plus C2 E minus 1 over 6x. That was the third step, which is find y. Now that we find y, we still do not have like the final form of y because we don't know C1 and C2. So as next step, it's going to find C1 and C2. How do we do that? We have those information here that are really valuable to find C1 and C2. So they said that like when y of minus 6 equal 1. So we're going to start with y minus 6 equal 1. We're going to replace, so y minus 6 equal 1. Okay, so we're going to use our equation just above here, oops, and replace x by minus 6. So in y, our y equal 1. So 1 equals C1 e 1 over 6 times minus 6 plus C2 minus 1 over 6 times minus 6. So when we simplify, we get C1 e minus 1 plus C2 e 1. But now we still like have the same problem. We still don't know what is C1 and what is C2. So we're going to use the second form that they're giving us, which is Greek prime of minus 6 equal minus 1. So they give us y prime minus 6 equal minus 1. And then we have the form of y equal, we have y equals C1 e 1 over 6x plus C2e minus 1 over 6x. We have y, but they're giving us y prime. So we're gonna have to derive this. Okay, well, let me call this step 4, which is find C1, C2. Now we want to find our second equation. We're going to derive this, which is equal to what? C1 1 over 6 x plus C2 minus 1 over 6 x. Now that we derive, we are gonna need to replace by the value here. We do the same thing that we did before. Minus 1 equal C1 1 over 6 e to the no, it's not minus, to the 1 over 6 minus 6 plus C2 minus 1 over 6 e to the minus 1 over 6 times minus 6. Okay, it's equal minus 1. It's equal, so C1 over 6 e to the minus 1 plus C2, if I do it like that, minus C2 over 6 e to the 1. These are our second equation. Second and first. So as you see, you have two unknown, C1, C2. Since you have two unknown, you're gonna have to find two equations, which you did. We did 1 and 2. Now that we have our two equations, we're gonna have to put them next to each other to be able to solve like a type of system. C1e minus 1 plus C2e 1. We're gonna want to solve a system, meaning we're gonna want to find to add them or to subtract them, and to have only one unknown. So it's either going to be C1 or C2. It's going to depend. So now that we know what we're doing, let's first rewrite this one here, because this is really not easy to solve. So let's say now we're going to multiply all of this one by 6. So we're going to rewrite this there. Just under it. So it's going to be minus, oops, just right here. It's going to be minus 6 equal C1e minus 1 plus, oops, minus C2e1. Now let's see what can we do here. We have a minus, we have a plus. So if we add those two values here are going to cancel each other. That's what we want. So we're going to add them. And then we're going to find 1 plus minus 6 minus 5 equal C1e minus 2 plus C1e minus 2, 2C1e minus 2, or minus 1. And those two cancel each other. So that's what we left with. And we want to solve for C1. So we're going to do minus 5 over 2e minus 1 equals C1. And how do we find C2? There's several equations that you can use. We have two equations here. So you can use either the first one or the second one. That's you pick which one you prefer. Gonna use the first one to find C2. So now that we have C1, we have our equation here, e minus 1 plus C2e1, right? So we're just going to replace C1 by C1 in there. 1 equal minus 5 to E minus 1. E minus 1 plus C2E1. Those two cancel each other. So what's left is 1 equal minus 5 divided by 2 plus C2E1. We're going to put this on the other side. So 1 plus 5 over 2 plus C2, oops, equal C2E minus C2E1. Okay, so now we simplify. It's going to be 7 over 2 equal C2E1. We divide by E1 over here, and we find our C2, and our C1 right here. Now that we find this value, we're gonna plug them back to our initial equation right here. So y is gonna be equal to our C1, which is minus 5 over 2e minus 1, and e to the power 1 over 6x, right? We'll check that, yes. And our C2, 7 over 2e1 times e minus 1 over 6x. And we just solve the problem.